Let us study the topic parallel vectors. What does it sense by telling that parallel vectors means two vectors? Suppose that these are two vectors, vector A and vector B. Okay, these are two vectors. These are parallel if and only if the distance between these two will be constant at any time, at any instant. If the perpendicular will be dropped and this perpendicular distance will be same, this d equals to this d at all the times. Okay, the distance between two vectors will remain constant, will remain same at any instant of time, then that two vectors will be parallel to each other. Okay, so let's define two vectors are said to be parallel if either they have the same direction or exactly opposite direction. Okay, two vectors if they have same direction or exactly opposite direction. The third point is they may differ in magnitude. Okay, may differ in magnitude. These 3 points make the definition of parallel vectors complete. Okay, the first point is they have the same direction, they may have the same direction or exactly opposite direction. Means same direction means theta equals to 0 degree. Okay, angle between them is 0 degree. Exactly opposite direction means theta equals to 180 degree. Okay, and they may differ in magnitude means their measurement, their lengths may be different, but their angle will be either 0 degree or 180 degree. This is okay, either this or this, either one of them will be valid. Okay, they may differ in magnitude. For the same direction we see, suppose that vector A is this and vector B is this. Okay, vector A and vector B, they are in the same direction. And for opposite direction we can see this is vector and this is vector B. They are in opposite direction although they are parallel. Okay, their angle is 180 degree. How it is 180 degree? Because if we put it on this in the same line, let it be extended. This is vector A, and if vector B is put here, just here, this will be like this. Their angle is 180 degree. Okay, this is also a parallel case. Okay, and one more thing here, parallel vectors are also called collinear vectors. Okay, also called collinear vectors. Okay, now this is the definition. Now let's see what are the conditions for a vector to be parallel. Now the conditions are, the first condition is vector A cross vector B. The cross product should be 0. This is first condition. Okay, there are actually 3 conditions. This is one condition. If the cross product is 0, we can say the vector is parallel. Vectors are parallel. How it is done? Let's see. Cross product is what? Vector A cross vector B equals to what? AB sin theta n cap. That is this. Here what? Theta is, for vectors to be parallel, what we see? Either it is 0 degree or it is 180 degree. In both the cases, theta, sin theta will be 0. Okay. If we put A, B and the value of theta is sine either 0 degree or 180 degree, in both the cases, either it is sine 0 degree or it is sine 180 degree, in both the cases sine value will be 0, and so completely it will be 0. So if the cross product is found to be 0, the vectors are parallel. The vectors are collinear, we can say. Okay, because it is also called collinear vector. This is one condition or second condition. This is one complete condition. Okay, so here we written or, not and. Okay, the second condition is a scalar product. By a scalar product we see, this is magnitude, this is also magnitude. A scalar product is equal to the product of magnitudes. Then the vectors are parallel or collinear. How it is done? Let's see. A scalar product means we know it is AB cos theta, and sorry, if it is AB and if we put the value of theta as 0 degree, okay, then cos 0 is what? 1. Cos 0 is 1, then it is AB equals to vector A this. So it is, this is also one condition because here theta becomes 0 degree. Okay, or it can be, if it is 180 degree, then what is the value of cos 180 degree? It is -1. So if we put, if theta equals to 180 degree, then it will be what? minus AB, and that will be equal to minus AB equals to minus then vector A, vector B, that is this. This is also a condition for vectors to be parallel. Okay, it can be written minus here, but let it go. And then another condition, one more condition is third one. If any one of the three is valid with two vectors, then the vectors are parallel. The third condition is vector A equals to any scalar product vector B. These vector A and vector B are equal by any scalar quantity. They are the vectors are equated by any scalar quantity. Okay, by multiplying any scalar, the vectors are equated. Suppose that we have to check that vector A is given as this is suppose that 4 5, and vector B is given as let it be 8 10, and we have to check whether they are parallel or not. So vector B can be written as this is taking 2h common, then 2 into 4. This is what? This quantity is vector A. So 2 into vector A, it came. Vector B came as a scalar, constant multiplied by vector A. So they are parallel. Okay, this is a condition. Okay, conditions for vectors to be parallel. And let's see the properties. Let's save the page here. Okay, let's see the properties. What are the properties of parallel vectors? What can be the properties? While studying this all, we can say cross product will be 0. Cross product of two vectors parallel will be 0. One property. Another property, when they will be parallel, it is simple. It is well clear that vectors will never intersect. So vectors will never intersect. And third property is what? Vectors may have different magnitudes. It can be written magnitudes may vary. Means they may have different magnitudes. It can be written that this is vector A, this may be vector B, vector A and vector B. The magnitude is just here smaller than this. Okay, although they are parallel, their magnitudes are different. They may have different magnitudes, but still they can be parallel by what conditions? Here is the condition. This is the main condition. Okay, let me mark it. This is the main condition. Theta equals to 0 degree, theta equals to 180 degree. This is the main condition. Okay, thank you.